Students, in this lecture we will proceed the topic partial derivatives, as we have studied in the previous lecture that how could we define partial derivative. uh, some notations are also shared with you people. For example, if we have a function u and u contains x, y and z, means that u is the function of x, y and z, then first order partial derivatives of this u with respect to x, y and z are denoted by del u del x, del u del y, del u del z respectively. These notations have already been studied in the previous lecture, and now just come to this notation. We can denote del u del x by ux. This x is the suffix or subscript of u, so it means that that is the first order partial derivative of u with respect to x. So whenever we take partial derivative of a function which is a function of several variables, more than one variable, then if you want to partially differentiate the function with respect to one variable, then the other variables will be kept constant. So in this case, if we want to find the partial derivative with respect to x, so y and z will be kept constant. Similarly, if you want to find the partial derivative of u with respect to y, then x and z will be kept constant, and whenever we find the partial derivative of u with respect to z, then x and y will be kept constant. So those are the first order partial derivatives with respect to x, y, z. Now secondly, we are going to mention here the second order partial derivative of u with respect to x. So that will be denoted by uxx, that is the second order partial derivative of u with respect to x, and that is with respect to y. Second order partial derivative of u with respect to y can be noted by this notation, and that is the second order partial derivative of u with respect to z. Now we need to concentrate this notation, because we see here that first of all u is partially differentiated with respect to x, then with respect to y. When we denote this as second order partial derivative of u with respect to x and y, we will write x and y in reverse order. We see here y is first and x is second, but if you want to denote this second order partial derivative, then we will write the variables in the reverse order, that is uxy in that notation. It means that u is partially differentiated with respect to x first and then with respect to y. So that is the second order partial derivative of u with respect to x, then with respect to y. And similarly, that is the second order partial derivative of u with respect to y, then with respect to x, and in this notation we will write these variables in the reverse form yx. So it means that u is differentiated partially with respect to y and then with respect to x. So these are all the notations for a function to denote its partial derivative. Now just look at this example. We are given a function u, x square plus y square plus z square plus xy plus yz plus zx. So u is the function of x, y and z, and we are asked to find the first and second order partial derivatives of this u. So the first order partial derivative of u will be with respect to x, y and z, and second order partial derivatives of u will be with respect to x twice, with respect to y twice, with respect to z twice, with respect to xy, and with respect to xz, with respect to yz, you may say that with respect to yx. So u is given to us, and the first order partial derivative of u with respect to x will be del by del x of this whole function. Now that is the partial derivative with respect to x, so y and z will be kept constants, so the derivatives of these two will be equal to 0. The derivative, there is no x, so the derivative of yz will also be equal to 0. So that is the sum rule of derivative, multiplying del x with all these terms. Derivative of x square is 2x, derivative of partial derivative of y square with respect to x is 0 because y is kept constant. Similarly, z is kept constant. Now that is the product of x and y. So y is kept constant, so take it out from this derivative y, just like that. So we are left with the del x of x. There is no x, so derivative of yz with respect to x is 0, and similarly z is kept constant, so z will be written outside this derivative. Now in the this step, that is 2x, y into 1, z into 1, so that is 2x plus y plus z. That is the first order partial derivative of u with respect to x. So that is the first order partial derivative of u with respect to x. Second order partial derivative of u with respect to x will be denoted by uxx. That is the partial derivative of ux again, and ux is 2x plus y plus z. Now the derivative of 2x plus y plus z with respect to x is 2 into 1. Y is constant, so the derivative of y is 0, and z is again 0, so that is 2 into 1 is 2. So that is the second order partial derivative of u with respect to x. Similarly, partial derivative of ux with respect to y, second order derivative. So uxy means partial derivative of ux with respect to y. That is the second notation. So uxy means partial derivative of ux with respect to y, and ux is 2x plus y plus z. Now with respect to y, partial derivative of this function is, that is constant, so that is 0, that is 1, and derivative of z with respect to y is 0. So partial derivative of ux with respect to y is 1. Similarly, uxz, we have obtained ux, so uxx, uxy, now uxz. It means that partial derivative of ux with respect to z, and ux is 2x plus y plus z, and with respect to z is x is constant, so that is 0, y is constant, so that is 0, and derivative of z is 1, so that is 1. So these all are the second order partial derivatives of u. Similarly, uy, partial derivative of u with respect to y, this u with respect to y. Now with respect to y, x square is constant, so that is the sum rule, so multiplying del by del y with all those terms. Now partial derivative of x square with respect to y is 0, partial derivative of y square with respect to y is 2y, partial derivative of z square with respect to y is 0, and that is the product of x and y, so x is constant right here, z is constant, so write it outside this derivative, and there is no y, so derivative of zx with respect to y is 0. Now in the other step, that is 2y, derivative of y is 1, so x into 1, z into 1, so there is 2y plus x plus z is the partial derivative of u with respect to y. So that is the first order partial derivative of u with respect to y, 2y plus x plus z. Now second derivative of uy with respect to y is del by del y of uy. Del by del y of this is uy, 2y plus x plus z. Now derivative of this function with respect to y is 2 into 1 plus 0 plus 0, so that is 2. Similarly, partial derivative of uy with respect to x uy with respect to x, that is uy, this whole function 2y plus x plus z. So with respect to x is 0 plus 1 plus 0, so that is 1. Similarly, partial derivative of uy with respect to z is del by del z of uy, that is uy from here, and with respect to z is 0 plus 0 plus 1, so that is 1. Similarly, with respect to z, partial derivative of this u is given by just like that, and that is the sum rule, so multiplying del del z inside, and that is with respect to z partial derivative, so that is 0 and that is 0, that is 2z, that is z is missing here, so that is 0, so z is here, y is kept constant, z is here, x is kept constant, and that is 2z y into 1 x into 1, so that is uz. Partial derivative of u with respect to z is 2z plus y plus x. Now partial derivative of uz second order with respect to z is just like that. Similarly, zx is just like that, and zy, that is partial derivative of uz with respect to y, just like that. So del by del y of uz, that is uz, 2z plus y plus x. Now with respect to y is 0 plus 1 plus 0, so that is 0 plus 1 plus 0, so that is 1. So that's how we find the first order and second order partial derivatives of a function containing more than one variables. Now let's go forward. In this slide we will study about the partial derivatives of functions. A function which is in the form of variable to the power variable. So that is question number 15 through 40. Find the first order partial derivatives of the following function. Question number 36, given that u is equal to x to the power y by z. So we see here that u is the function of x, y and z. U is the function of three variables x, y, z. So first order partial derivative of u will be with respect to x, with respect to y, and with respect to z. Now we need ux, uy and uz. As we see that u is the function of x, y, z, and u is in the form of variable to the power variable. Whenever this situation arises, so we will take natural log on both sides. So taking natural log on both sides, natural log of u is equal to natural log of x to the power y by z. Now using the property of log, this power will be dropped down here, so y by z into log of x, that is equation number 1. So first of all we will partially differentiate the function with respect to x. So partially differentiate equation 1 with respect to x, del by del x of log of u, del by del x of this whole function. Now partial derivative of log of u with respect to x can be written as 1 by u del u del x, and that is with respect to x. So y by z is constant here, so this should be outside this derivative, and that is the partial derivative of log of x with respect to x. So partial derivative of log of x with respect to x is 1 by x, and that is y by z, so y into 1 is y, and that is zx. So 1 by u del x is equal to y by zx. Multiplying both sides by u in order to find del u del x, so multiplying both sides by u, so this u will be cancelled out, and we will be left only del u del x is equal to u into y by zx. And this notation can be written in this form as ux is equal to the value of u from here is x to the power y by z. So that is the value of u, x to the power y by z, into y divided by zx. So that is the first order partial derivative of u with respect to x. Similarly, differentiate this equation 1 partially with respect to y. Differentiate equation 1 partially with respect to y, this equation 1. So that is del del y of log of u is equal to del del y of y by z into log of x. So that is just like that function, just like that. So that will become 1 by u del u del x del u del y, sorry, and that is with respect to y. So log of x by z is kept constant. So writing log of x by z outside this derivative, and we are left only del y del y. So that is del by del y of y, and this is equal to 1. So that will become log of x divided by z. So that is 1 by u del y is equal to log of x divided by z, multiplying both sides by u, and replacing this u by its own value from the given question, x to the power y by z. So that is first order partial derivative of u with respect to y. Similarly, first order partial derivative of u with respect to z, we will partially differentiate this equation 1 with respect to z. So with respect to z, that will become just like this function, but here is z, variable z, and because this is with respect to z, so y into log of x will be kept constant, and transferring this z into numerator, so that will become z inverse. So y log of x del del z of z inverse, and that is power rule actually. So the derivative of z inverse is minus 1 z minus 1 minus 1, and writing this minus sign outside here, y log of x z to the power minus 2. So 1 by u del z is equal to minus time y into log of x divided by z square, multiplying both sides by u. So that is del u del z is equal to minus u into this whole function, and replacing u by its own value. So that is how could we find the partial derivatives of a function whenever a function is in the form variable to the power variable. Question number 28 is the same. In question number 28 there are two variables, so that will become more easier than this question. So that is how could we find the partial derivative of function which is in the form variable to the power variable, that we will taking natural log on both sides. Now in this slide we see here that we are given data u is equal to sine of x1 plus 2x2 plus 3x3 plus and so on plus nxn, that is say equation 1. U is given to us, and we need to find the first order partial derivatives. So there are n variables in this question, x1 x2 x3 up to xn. So we need ux1 ux2 ux3 and so on uxn. First of all, we need to find ux1. So for ux1 we need to differentiate partially equation 1 with respect to x1. So ux1 is equal to del del x1 of this whole function. Now that is actually the angle of this sine, that is u, actually sine u. So what is the derivative of sine u? That is cos u, this whole u, and to further derivative of this u. Now that is the further derivative of this angle, and we see that this derivative is partial with respect to x1. So x1 will be considered as variable, and other xi's will be kept constant. So all those derivatives will become 0, and the derivative of x1 will be equal to 1. So that is ux1 is equal to cos of this whole angle, and the partial derivative of this whole function is with respect to x1, that is 1, and the rest of all the terms will be equal to 0. So 1 into this function is actually the same function. So that is the first order partial derivative with respect to x1. Similarly, partially differentiate equation 1 with respect to x2. So that will become ux2 del del x2 of sine of this whole angle. So again, sine of u, sine of u is cos of u, and to further derivative of this angle again with respect to x2. Now that is the derivative with respect to x2, so x2 will be considered as variable, and all other xi's will be kept constant. So the derivative of x1 will be 0, the derivative of 2x2 will be 2 into 1, and the rest of the terms will be equal to 0. So we are left only with 2, so write this 2 in front of cos, so that is 2 cos of this whole. So just look at that, if that is ux1, so 1 is multiplied in the front of cos, and that is x2, so 2 is multiplied in the front of cos. So similarly and so on, partially differentiate this function with respect to xn. So uxn will be equal to del by del xn, that is actually xn, correct this subscript of sine u. Now the derivative of sine u is cos of this whole, and to del xn of this whole angle. Now that is the partial derivative with respect to xn, so this will be considered as variable, and rest of the terms will be kept constant. So the derivative of these terms will be 0, and the derivative of the last term with respect to xn is n into 1. And now writing this n in the front of cos to get the derivative of u with respect to xn. So that is actually question number 40. In this slide we will be discussing the indicated partial derivatives. We are given a function, r is a function of s and t. Just look at this function. This function contains t and s, so this function is denoted by r, and r containing t and s, or we may say s and t. So we need to find rt01. What does it mean? First of all, find the partial derivative of r with respect to t, and then replace s by 0 and t by 1. Find the partial derivative of r with respect to t, and then replace s by 0 and t by 1. So partially differentiate r with respect to t, so that is the notation. Rt of st is equal to del t of this whole function. So we see here that this is the product of two terms, t e power s by t. Both the terms, or we may say that both the factors containing t. So this is product rule. What is product rule? First function, derivative of the second function, second derivative of first function. Now that is the derivative of e power u. Derivative of e power u is the same e power u, and to del t of this power s by t, and derivative of t is 1. Now derivative of this fraction with respect to t is kept constant, so right here this is outside this derivative, and shifting this t towards numerator, so that will become t inverse, and this is now power rule. Now using power rule, that will become minus 1 t minus 1 minus 1, writing this minus outside this whole term, and that is st, that is actually t power minus 2 e power s by t plus this e power s by t. Now e power s by t is common in these two terms, so that is common. We are left with minus s, these two are same, so power will be added, t power 1 minus 2, and here we are left with 1, that is t power minus 1, and t power minus 1 is just like that, s by t, so minus s by t plus 1, so that is the partial derivative of r with respect to t containing s and t. Now replacing s by 0 and t by 1. So whenever we replace s by 0, t by 1, we will get this rt of 0 1, so that will become e power 0 by 1 minus 0 by 1 plus 1. 0 by 1 is 0, so e power 0. 0 by 1 is 0 plus 1 minus 0 is 0, so 1 into e power 0 is 1, so 1 into 1 is 1. So RT of 0 1 is 1. So that is the first order partial derivative of r with respect to t when s is 0 and t is 1. Question number 42 is the same, just like that. Use the product rule to find the mentioned indicated partial derivative. Now here we are, question number 43, the same statement, find the indicated derivative. We are given a function of xyz, log of this by that. So first of all, simplifying this function using the rules of log, that will become log of m by n. So log of m minus log of n. So that is the function. We need to find fy of 1 2 2. What does it mean? Differentiate partially this function with respect to y and then replace x by 1, y by 2 and z by 2. So partially differentiate this function with respect to y, we'll get fy of xyz del y of this whole function. Now using the formula log of u, the same log of u, that is the difference rule, del y of this function minus del y of this function. So log of u is 1 by this u del y of this function again, and that is the same as this function. Now partial derivative of this whole function with respect to y, partial derivative of 1 is 0 and partial derivative of this is, that is actually whole power 1 by 2. So whole power 1 by 2, that is extended power rule, dropping 1 by 2 here, 1 by 2 is missing here. So that is actually extended power rule. Derivative of 1 is 0 and that is x square plus y square plus z square whole power 1 by 2. So dropping 1 by 2, 1 by 2, 1 by 2 minus 1, further derivative of x square plus y square plus z square. Similarly here, that is partial derivative of y partial derivative of this function with respect to y. So derivative of 1 is 0 and that is again the same situation is here. So that is 1 by 2, 1 by 2 minus 1, further derivative with respect to y of this function. Now in this step we have kept this 1 by 2 common here, 1 by 2, that is minus 1 by 2 minus 1 is minus 1 by 2, and partial derivative of this function with respect to y is 2y, that is 0 and that is again 0, so that is 2y. Similarly here 1 by 2 is kept constant, common 1 by 2, and that is 1 by 2 minus 1 is minus 1 by 2, and derivative of this function with respect to y is 2y again. Derivative of x square is 0, z square is 0, so that is 2y. Now that 2 and this 2 cancelled out. Similarly here this 2 and that 2 will be cancelled out, and x square plus y square plus z square to the power minus 1 by 2 is common, and y is also common in these two terms. So we have taken x square plus y square plus z square power minus 1 by 2 common and y also common, and here we are left with 1 by this function, actually minus 1 by this function and minus 1 by this function. That 2 is already cancelled out. Now in further step, minus 1 by 2, if we shift this term towards the denominator, so that will become the square root, and that is the partial derivative of this function with respect to y. Now we need to put x equal to 1 and y equal to 2 and z is equal to 2 in this function. So whenever we replace x by 1, y by 2, z by 2, these are the calculations, very fair calculations, I mean very simple calculations. That is 9, 9, 9, square root of 9 is 3, so 2 by 3 minus 1 by 1 minus 3, 1 plus 3, and minus minus cancel. 4 is the LCM, so 2 minus 1, 2 ones are 2, 2 twos are 4, 2 3s are 6, so 1 by 6. So that is the partial derivative of the function whenever x is 1, y is 2, and z is 2. Now in this slide we will verify the conclusion of Clairaut's theorem. That is actually Clairaut's theorem, that derivative of u with respect to x then with respect to y is equal to partial derivative of u with respect to y then with respect to x. These will be equal, these will be same. When a function is continuous, so the partial derivatives, the second order partial derivatives of that function, by changing the order of derivative, changing the differential order, is always the same. uxy is equal to uyx. We are given, that is from equation 50, question number 59 to 62. And question number 59, we are given this function u. First of all, we will find uxy, then we will find uyx and check whether these two are same or not. So for uxy, first of all we find ux, partial derivative with respect to x, and then with respect to y. So ux will be equal to partial derivative of this function with respect to x, partial derivative of this function with respect to x, partial derivative of x4 is 4x cube, y cube is constant, and this term is free from x, so derivative of y4 is 0. So we are left with ux is equal to 4x cube y cube, that is ux. And now we need to differentiate this ux with respect to y, uxy, differentiating ux with respect to y. So with respect to y, derivative of ux, this is ux. So with respect to y, that is 3y square, 4x cube into 3y square, 4 3s are 12, 12x cube y square, that is uxy. Similarly for uyx, first of all we need to find uy, differentiating this u with respect to y. So with respect to y, that is 3y square into x4, and that is 4y cube with respect to y. So there is 3x4y square minus 4y cube, that is uy, and then we need to differentiate this uy with respect to x. So uy with respect to x is del by del x of uy, that is uy. Now with respect to x, that is 4 will be dropped down, that is actually the sum difference rule, and derivative of this function with respect to x, 3y square is kept constant, and that is derivative of x4. X is missing here, so derivative of this function with respect to x is 0. So that is 3y square, and derivative of y4 is 4x cube. 3 4s are 12, y square x cube, so that is the uyx 12x cube y square, that is equation 2. Now just look at that, uxy is 12x cube y square, and uyx is again 12x cube y square. So from equation 1 and 2, uxy is equal to uyx. So Clairaut's theorem holds for this function. Whenever these two are not same, then we say that Clairaut's theorem does not hold for the given function. (59 to 62). Now we are considering here question number 61. Function u is given to be cos x square y. First of all, we need to find ux. So ux means derivative of this function with respect to x. So derivative of cos u, derivative of cos u is minus sine u into further derivative of this u with respect to x. Now further derivative of this angle with respect to x, y is constant, and that is derivative of x square, and derivative of x square is 2x, so that is 2xy into sine x square y. So that is minus 2xy into sine of x square y, that is ux. Now we need to differentiate this ux with respect to y. So ux with respect to y is del by del y of ux, that is ux del by del y. So that is the partial derivative with respect to y. So minus 2x is kept constant. So write minus 2x outside this derivative, and that is the product of two functions, y into sine of this function. So that is product rule. First function derivative of second function plus second function derivative of first function. Now that is the derivative of sine x square y with respect to y. So derivative of sine u is cos u, further derivative of this u, and that is sine x square y into 1. That is 1. Now further derivative of this function with respect to y, so x square will be kept constant, x square, and derivative of y is 1. So that is 1. So we are left with uxy is equal to minus 2x into x square into 1 is x square. So x square will be written here, x square y into cos of x square y plus sine of x square y. So that is uxy. Similarly for uyx, first of all we need to find uy. Uy means partial derivative of u with respect to y. So partial derivative with respect to y, cos of u, derivative of cos of u is the same minus sine of u, further derivative of this u with respect to y. So that is with respect to y, so x square is kept constant and derivative of y is 1. So that is x square into 1. Writing x square here, so minus x square into sine x square y, that is uy. Now we need to find the derivative of uy with respect to x. So derivative of uy with respect to x is del by del x of uy. So del by del x of this is uy. So that is the derivative of this function with respect to x. So that is again product rule. Minus is kept constant, and that is product rule. So that is first function derivative of second plus second derivative of first. That is the partial derivative of sine u with respect to x. So that is cos u into derivative of this u again, and derivative of x square is 2x. Now that is the partial derivative of x square y. So y will be kept constant and derivative of x square will be 2x. So that is 2xy. That is 2x into sine x square y. Now we see here that 2x is common in these two. 2x is common, so taking 2x common, so we are left with the x square y cos of x square y plus sine x square y. That is equation 2. Now from equation 1 and 2, these two are same. So uxy is equal to uyx. So for this function, Claire's theorem also holds. In question number 47 through 50, we need to use implicit differentiation to find del z del x and del z del y. Del z del x mean z is the function of x and z is the function of y as well. So whenever we partially differentiate the given function, so z will not be kept constant. Just look at that. Whenever you differentiate with respect to x, only y will be kept constant and z will not be kept constant. So in question number 47, we are given this function x square plus 2y square plus 3z square is equal to 1. We need to find del z del x and del z del y. So for del z del x, we need to partially differentiate this equation with respect to x. So partially differentiate equation 1 with respect to x. That is del x of this whole function is equal to del x of 1. Multiplying del x inside, so x square, derivative of x square with respect to x is 2x, and derivative of 2y square is 0, and that is 3z square. Remember that z is the function of x and y, so don't make it 0. We need to find the power rule, extended power rule here to find the derivative. So 3 will be kept constant here, and derivative of z square with respect to x is 2z2 minus 1, and into further derivative of z with respect to x. Now that is 6z, 2x is shifted towards right side, so that will become minus 2x, and that is 3 2s are 6 into z del z by del x. Dividing both sides by 6z, to get del z del x is equal to minus 2x by 6z. 2 3s are 6, so that is del z del x is equal to minus x divided by 3z. So that is the partial derivative of z with respect to x, which is obtained here. Now again, differentiating equation 1 with respect to y, both sides with respect to y. So with respect to y, derivative of x square is 0, and derivative of 2y square is 2 2s are 4y, and that is again derivative of partial derivative of 3z square with respect to y. Partial derivative of 1 is 0. Now again 3 is kept constant, and derivative of z square with respect to y is the same 2z2 minus 1 del z del y is equal to 0. Shifting 4y towards right side, so that is 4y, 3 2s are 6, z power 1 del z del y. Shifting 4y towards right side and dividing by 6z to get del z del y is equal to minus 4y by 6z. 2 2s are 4, 2 3s are 6, so that is del z del y. So that's the same question that use implicit differentiation to find del z del x and del z del y. Given that in question number 49, Ez is equal to x y z. Partially differentiate this equation with respect to x, both sides, to get del del x of Ez and del del x of x y z. That is e power u. So derivative of e power u is the same e power u into derivative of the power del z del x is equal to, that is partial derivative with respect to x, so y will be kept constant, x and z are variables here. So using the product rule, first derivative of second plus second derivative of first, and that is multiplying y inside, so yx into del z del x plus yz into 1. So that is e power z del z del x is equal to this whole thing, and combining the terms containing del z del x, so transferring this term towards left side, that will become negative sign, taking del z del x common in these two terms to get Ez minus Eyx, so is equal to yz, is equal to yz. And in order to find del z del x, we need to divide Ez minus Yx towards that side. So del z del x will be equal to yz divided by Ez minus Yx. So that is actually del z del x. Similarly, for del z del y, we need to partially differentiate this equation with respect to y. So with respect to y, both sides, e power u, derivative of e power u is the same e power u into del z del y is equal to, now here that is partial derivative with respect to y, so x is constant, keep it constant outside, and that is y into z. Using product rule to get these two terms, and del y is 1, multiplying x inside, xy del z del y plus xz into 1. So that is Ez del z del y is equal to this thing. Now transferring this term towards left side and taking del z del y common in these two terms to get this equation, and in order to find del z del y, we need to divide this term towards that side. So that is del z del y. So that is how we find partial derivative of a function with respect to two different variables.